Hello and welcome back to our discussion on strings. And in this video we are going to be looking at this string library right here, and we're going to be looking at a few functions. The rest of them you can look them up if you need it at some point, but I just want to introduce you to some of them which are the most commonly used ones. So let's first just go ahead and create a couple of strings. So let this be str1 and this is going to be hello. Let's have an str2 which is world, and what I want to do now is I want to concatenate these two. So basically what I want as my result is hello world, let's just say for now. Let's just not add a space here. So that's what I want to do, and for that we have a function called str.cat, and that cat basically stands for concatenation. So strcat basically takes two arguments. The first one is the destination and the second one is the source. So this destination is basically the string into which we are going to concatenate. So this destination will probably be my str1 and my source will then be str2, and at the end of this operation what's going to happen is whatever was in str2 is going to get added to the end of whatever was in str1. So let's just try and print str1 after this. So I do this printf right here, and let's just try running this program now. So I do gcc strings.c -o strings, and then let's just run this, and as you can see I've got the entire hello world right here, and I just printed str1. I didn't print str1 and then str2. So basically what it means is that at the end of this function my str1 became equal to something like hello world, and if I want a space between my hello and world, I can always do something like this: strcat str1 and then a space here, and at the end of this operation right here my str1 is going to be equal to something like actually let's just use a single equals here, that makes more sense. So we're doing str1 equals hello space, and at the end of this operation now my str1 is going to be hello space world. So let's try running this now, and as you can see I've got hello space world. So that's about the strcat function, and very similar to the strcat function is the strncat function, and what that means is basically once again it takes a destination, it takes a source, but it also takes after these an integer n, which basically stands for the number of characters that we want from this source string to be concatenated. So let's just actually change this to computer and this one to programming, and let's just give str1 here and let's give str2 here, and for my n I'm just going to say let's say I want till this m right here, so I'm going to give it 1 2 3 4 5 6 7. So I give it a 7 here, and let's just go ahead and try this out. I forgot a semicolon right here, and let's try this. As you can see I've got only computer program here, and this MING got lost. When I say got lost, it's obviously still stored in str2, but it wasn't concatenated to the end of str1, and that's because we gave it a 7 here. And remember that this 7 just means that do at max 7 characters. If I had something like hello and world here, and even though I'm saying 7 here, it would just concatenate 5 characters, and that's because it just has 5 characters to concatenate. So let's do this first, and as you can see, I've got just hello world. So basically what it says is, what this 7 here says is that concatenate 7 characters, or just concatenate till you find a \0. That's what this 7 right here means. So that's how you can concatenate strings. And similar to concatenation, we also have a string copy function. So there's an strcpy, and let's just say I want to copy, again it's destination comma source, that's the syntax. So I do strcopy str1 and str2, and let's go ahead and run this now. And as you can see, it just has world now because it copied the contents of str2 into str1. Also remember that doing something like str1 equals str2 is not going to work. That's actually very invalid, and it gives me an error right here. And that's basically because what str1 stands for is the name of this array, which stands for the starting address, and we're trying to say that the starting address should now be str2. The starting address str1 should now be equal to str2, which doesn't really make any sense. So just remember this thumb rule: array name equals something is always wrong. So don't ever do that. So strcopy basically does that job for us. And if I have some data in str1 which I actually want, then this is not a good option because the data in str1 is lost after this operation. And let's once again make this computer and make this one programming. And this time the lengths of these two are different. So let's just see what happens now. It didn't give me an error, so that's one point that I need to keep in mind. And it gave me the entire string, the entire programming thing right here. So basically it copies till it finds the \0 of the second string, and that's basically copying the entire second string into the entire first string. So that's how it does the copy. But if I want to say something like just copy 1, 2, 3, 4, 5, 6, 7 and 8 characters, I can always use something like strncpy and then give it an 8 right here. And let's run this now. It just gives me programm. This ing is lost because 8 characters is still right here. So just like we had strcat and strncat, we have strcopy and strncopy. Once again, this 8 means a maximum of 8. If it just has 5, if I had hello and world and I gave it an 8, it would just copy 5 and then stop because it got a \0 at that point. So that's about the strcopy. And another one that I want to talk about is the strchr function. So what the strchr function does is it gives me the first instance of a character in a string. So let's just do this once, and let's take a look at what happens. And actually I want this to be in some integer n, and let's just get rid of this line and do printf and %d and n, and let's try running this. And this is giving me a warning because what this strchr actually gives me is the address of this character m in this string right here. So what I should do is I should just do a char star here, and let's also just, instead of printing this, let's print I'm going to do a %p right here, and then I'm going to do a %p again, and then I'm going to do n here. Let's try this now, and let's actually add a \n right here. And as you can see, I've got two addresses, and the first address that I got was some FFFFCBEF. That's the first address that I got, and that must be the address of this C right here. So what comes after EF? The next thing would be an F0. So let's take a look at that right here. So what comes after an EF? That would be an F0, because that's how you do hexadecimal counting, right? You increment the least significant bit, the least significant digit, and then if that goes beyond an F, you make it a 0, and you do a carry on the E, and then the E plus the carry becomes an F, so you get an F0. After that, I would have an F1. So this F0 must be the address of this O. The F1 must be the address of this M right here, and that's what I said I was looking for, the M. So that's what I should have got, and as you can see, that is indeed what I've got here. I've got a CBF1, so it's actually the memory address of this M right here. And let's say I want the position of this M. It's actually pretty simple to calculate that. I just do an int POS, let's say, for position, and let's just do n minus str1. So, and let's just typecast this to an int, and let's print a POS here, and let's try running it now. So as you can see, it gives me a 2, which is correct, because this C is 0, and then a 1, and then a 2. So that basically gives me the index of this M right here. And let's just do one thing at this point. I'm going to do something like some random A, B, C, D, and then M, M, M. And let's just run it this time, and as you can see, it gave me a 4. So this one is 0, 1, 2, 3, and 4. So it basically gives me the index of the first one right here, but let's just say I want the index of the last one. What do I do in that case? All I have to do is add an R here. So strrchr is basically string reverse character, and then let's just run this now, and let's do this. As you can see, it gave me a 6, because this one was a 4, this one right here was a 4, this one is the 5th one, and this is the 6th one. So this strrchr gives me the character from the end. So that's about strchr, or finding a character in a string. And similar to this, we also have something called strstr, which basically looks for a substring. So let me just demonstrate that to you. I'll do a char star n equals strstr, and then let's just say I'm looking for, in str1 I'm looking for mmm, and let's just do a printf %p, sorry about that, %p, and then n right here, and let's just save this, and let's run this now. So it gives me a CBF4, and if this one was an EF, This would be the B would be F1, the C would be F2, the D would be F3, and this M would be F4. But let's just say I do something like M, and let's try running this now. This shouldn't actually work because this M does not actually appear in str1. So let's hit enter now, and as you can see, it just gives me 0. When it gives me 0, that means that oh, I couldn't find the address of any such substring, or it would also give me a 0 if in this string I do an strchr and I give it something like an E, because there is no E in there. So that's when it gives me a 0, and that's just str for you. And there's also other functions related to str, like we had strrchr and all, but I'll leave that up to you. You should look up the functions in string.h and just take a look at the ones that look useful, like this finding substrings might be really useful in some cases. So that's about this string library that basically brings us to an end of our discussion about strings. But I want to discuss string arrays in the next video, but I think it'll be a short one, so I'll see you there.